Okay, so I'm on your Unit 8 packet on page 3. So if everyone can turn to page 3, we're going to talk about sequences today and what a sequence is. So a sequence is an ordered list of numbers. Each number of a sequence is called a term. So we're just going to go over some definitions here. A finite sequence contains a finite number of terms. Now, finite means a certain number, so it's not going to go off into infinity. It stops at a certain point. An infinite sequence contains an infinite number of terms, so they're going to keep on going off forever. Now, it's weird. We call this infinite, but this isn't finite sequence. It's finite sequence. So a finite sequence and then an infinite sequence. The terms of a sequence are referred to in the subscripted form shown below, where the natural number subscript refers to the location of the term of the sequence. So what I mean by that is, okay, this is an example of a sequence. 1, 4, 7, 10, 13, 16. So this is a sequence because it's just an ordered list of numbers. We just have a list of numbers. And what it means by a natural number subscript is this first number would be A1 because that subscript means it's 1. A2, A3, A4, A5, and A6. So this means the first term, the second term, third term, fourth term, fifth term, and sixth term. All right, so the general form of a sequence is represented by A1, then A2, comma, A3, that's a comma there, comma, A4, comma, A5, until we could keep going off based on how many numbers of the sequence that we have. And the domain of a sequence consists of the counting numbers, and the range consists of the terms of the sequence. The terms of the sequence may or may not have a pattern or a related formula. So some will have a specific pattern how you get to each number, or a formula, same thing, and some will be completely random. So the ones that we will talk about in class have a specific pattern. So a pattern and an explicit formula, these are the same things. So let's say I have AN. Now here my subscript is an N because N can be any number. It can be the 1, 2, 3, 4, because this is a general formula, is equal to 12 times N. So here my variable is N. So N represents the term's position in the sequence. So let's do an example of this. Let's say I want A1. A1 designates the first term. So if I want A1, so N is 1, that means I'm plugging in 1 for N. So that's 12 times 1 is equal to 12. A2 means I'm going to plug in 2 for N. Also, make sure, I should have done this 2 smaller because it's a subscript. So make sure it's small. So 12 times 2 gives us 24. I plugged in 2 for the N there. If I want a tiny 3 because it's a subscript, that means I'm going to have 12 times 3, which will give me 36. And I could keep going off into the whole sequence, but now I know the first term is 12, second term is 24, third term is 36, and then my sequence will keep going. Okay, so let's go through some examples. So So the first example is, the formula is going to be an is equal to 2 times n minus 1. And my example says write the first 3 terms of the sequence. So first 3 terms means I'm going to plug in 1 for n, and then 2 for n, and then 3 for n. So if I want a1, that's going to equal, so the first term, 2 times 1 minus 1. Well, 2 times 1 is 2. 2 minus 1 is 1. Now I want to find a2, tiny 2, subscript 2, the second term. So that means 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1 is 3. Now I want the third term. So 2 times 3 is 6, minus 1 is 5. So that means my first 3 terms are 1, 3, and 5. Okay, let's turn the page over. So this second example says find the 5th and the 10th terms. So if I want the 5th and the 10th, that means I want a5 and a10. So that means I'm plugging in 5 for n, and I'm plugging in 10 for n. So plugging in 5, I'm going to use this formula. 5 over 5 plus 1 is equal to 5 over 6. And then for 10, I'm going to have 10 over 10 plus 1, which is equal to 10 over 11. Okay, number 3. So now number 3 says write an explicit formula for the nth term. So if I have -2, -4, -6, -8, I want to figure out a formula, so an equals, how would I get these terms of the sequence? So I know here I am subtracting 2 each time, -2, -2. So if I want to figure out a formula with that, I'm going to say an is equal to -2 times n. So this is the formula that would, if n is 1, -2 times 1 gives me -2. If n is 2, -2 times 2 is -4. If n is 3, -2 times 3 is -6. So my terms are -2, -4, -6, and -8. My notation is first term, second term, third term, fourth term. So the location is the first term, the second term, the third term, and the fourth term. So this equation would satisfy that number of terms. Okay? Now, looking at number 4, what are the first 4 terms of the sequence? So I want a1, a2, a3, and a4. a1 is going to be -1 to the first power times 1 squared plus 3. So I plugged in 1 where I saw the n. So n was an exponent here and a number here. So -1 to the first power is just -1. 1 squared is 1, so I have 1 plus 3, which is 4. So this is -1 times 4, which is -4. Plugging in a 2, oops. I'm going to have -1 squared is -1 times -1, which turns into a +1. 2 squared is 4. 4 plus 3 is 7, so I have 7 times 1 is 7. And now I have -1 to the third power times 3 squared plus 3. -1 to the third power, -1 times -1 is a +1. +1 times a -1 is a -1. So -1. 3 squared is 9. 9 plus 3 gives me 12. So -12. Here I'm going to have -1 to the fourth and 4 squared plus 3. So negative 1 to the 4th power, you'll see if I have even exponents like the 2 and the 4, I'm going to have a positive 1. And whenever I have odd exponents like 1 and 3 for a negative 1, that means I'm going to have a negative 1. So negative 1 times negative 1 is positive 1. Positive 1 times negative 1 is negative 1. Negative 1 times negative 1 is positive 1. So positive 1. 4 squared is 16, and 16 plus 3 gives me 19. So 19 times 1 is 19. So that means my first 4 terms of the sequence is negative 4, 7, negative 12, and 9, which is outlined right here in our packet.